So problem 55, we're going to solve this with RREF, that is reduced row echelon form. We're going to start by putting this into an augmented matrix. So it's going to look like that in our calculators. There we go. So matrix A, and a quick way to get at the solution is to put that in reduced row echelon form. So hit the second key, then the X inverse key, which takes you to the matrix menu. Let's go over to math. If you go up rather than go down, might get there a little faster. I want this in reduced row echelon form. We want a reduced row echelon form of what? You have to tell it what. Matrix A. So go back to your matrix menu and get reduced row echelon form from matrix A. What you'll notice is that the bottom row of this is all zeros. So that's telling us a little something about our system of equations. It's a dependent system. Essentially, this bottom equation says that 0 equals 0, which is true. If you add zeros here and then a number here, that'd be an inconsistent system, so it'd be false. But let's write down what this represents for us as a system of equations. So the first one represents, let's see, x plus z equals 5. The second one represents y minus 5z equals negative 3, like that. So there you go. And the last one is kind of anything, right? Z can be anything. But understanding that we've got expressions that involve x and y, we can solve for each of these. So let's do that. This is x equals negative z plus 5, y equals 5z minus 3. The only thing we haven't specified is z. Z can be anything. So we're just going to let z equal z. As far as the solution to your system of equations is concerned, that means we have negative z plus 5, 5z minus 3, and z. So once you choose a value for z, then you get values for everything else. So for instance, if you chose z equals 0, so at z equals 0, you'd end up with 5, negative 3, and 0. That would be a point on your line. But any value of z is going to give you a solution. Because really, effectively what's happening is you've got two planes that intersect each other along a line. And this is a parameterized version of the equation of that line. That's what's going on. All right? Just a heads up, the book's not going to use z like I do. Most books tend to use a t, so they'll go minus t plus 5, 5t minus 3, and t. And there's other varieties, other ways you can write this solution, but I mean, there's nothing wrong with z or t. Whatever is most comfortable for you. Does that help? Cool.